How do you think a wing creates a lifting force?
I always thought like the air gets underneath it somehow because of the angle of it kind of pushes it up. How does it work?
Well, actually, what many people think that the pressure is lower on the top or higher on the bottom and lower on the top, so the change in pressure would lift it, and that's somewhat true. But it's also many other kinds of things that work together to kind of produce a lift. So there's like an angle of attack. So most of the wings on planes are like kind of angled a little bit. So the plane can kind of do what you were saying and get off the ground that way. And when you're taking off, it kind of has a high angle of attack as it goes up, and the rudder or the little, like, I don't know what you call them, but the little rudder things, the flaps on the plane wing will tilt down to direct all the air downwards to get lift off the ground. So you said that the plane is actually, the air pushes it up because of the shape, but then how does the plane fly upside down?
I don't know, maybe the flaps change?
Yeah, that's probably I don't know. I don't know. That's how it is. That's literally how they do it.
Okay. Well, there we go.
So here we have two examples of different kinds of airfoil. So here we have the upright airfoil and the inverted. So this kind of gives an example of how like planes work to fly upside down. So with the upright airfoil, that's just typical airfoil. The air comes in here. This kind of illustrates it. So the brunt force of the air kind of hits the stagnation point right here, and then it kind of either splits this way or kind of goes along the bottom. So this is kind of the angle. See how it's a little tilted? So like from this axis, so it's kind of tilted like this. Like this is the wing and here's the angle. So when it has an angle, it's able to get more lift. And here with the inverted airfoil, we can see that it's kind of basically the same idea, but it has to have that angle attack to maintain lift, because it has a different kind of static, like here how it says streamlines crowded together, local static pressure, because that's along the flat side. So it would actually be forcing it down, but because of the angle of attack here, we can see that it's actually able to maintain lift and fly upside down. Here I have multiple airfoils, so here's, let's see, here's the typical airfoil where it has a flat bottom, yes, okay. So this one has a flat bottom, and then like along the top it's curved, so that's where like the difference in pressures gives it lift. So you can kind of feel this in the wind. Yeah, so it kind of spins a lot around a little bit. So and then yeah,
there's a biplane.
And this other one, this one has, they call this the like it's kind of like a balanced airfoil, so it's like it's even on both sides. Each side is kind of like symmetrical. That's what it is, symmetrical airfoil. So that one you can feel the lift a little bit more. It kind of goes up. And then this one's called like a cambered airfoil. Let me fix this. And this one, it's kind of flatter, and then it curves along here. So that's what directs the force down. So you can kind of feel it. Yeah. And that one's a little bit more unstable because when you have that angle of attack right here, it gives you more drag. So like it's like you're sticking your hand out of like a car window when you're like this. Like when you're like this, then you have like you can't feel it. But when you go like this, then all of a sudden you feel it pushing back. So what happens is like since this is curved a little bit like this, you're gonna feel more drag. So that's why when it flies, you have to have more like, I guess, engine power or whatever, or speed to keep it from stalling. So when a plane takes off, it actually pulls up, like when you're sitting in the plane, you can feel the plane pulling up like this. So that's like gravity pulling down. And then because of the angle of attack that it's having, you're having more drag, so you're actually going slower in the X direction right here, but you're actually going higher in the Y direction. But because of that, the more drag, once it gets up to cruising altitude up here, the pilot's actually able to speed up because there's less drag and just use the airfoils on the wings to just keep it up. But here, to get the lift it needs to get all the way up to cruising altitude, he uses that angle of attack to his advantage to get up there. And then once he's up there, he just cruises with the wings. We're going to have a demonstration of the different kinds of airplanes. So this one, it's just kind of flat, doesn't really have an angle attack here, and it's just flat, kind of not really foiled at all. Second one, we do have the angle of attack right here. You can see how it's slanted like that, and then it doesn't have a foil, but it's flat and it has that angle of attack to give it enough lift to get off the ground. This other one, let's see. This one indeed has the airfoil, and it's flat, doesn't have an angle attack. And then now we're going to test to see which one flies longer and farther, I guess. A little bit of wind today, so we'll see how this works. Alright, first up we have the angle attack. Alright. Second one, we have the flat, normal paper airplane. Alright, and then here we have the foiled paper airplane. Alright, wind's picking up. Alright. Okay, so we can see, so the angle of attack plane actually kind of went straight, then kind of just into the ground because it really doesn't have any lifting force after all its power is gone, because it's just using the angle to get kind of some sort of lift. And the flat one just kind of went straight into the ground because it doesn't really have anything helping it. It doesn't have an angle attack, doesn't have really any sort of foil to keep it up. But the airfoil one actually did maintain a nice straight line into the ivy over there. So I think the airfoil actually does work in getting a paper airplane to go in a straight line. Alright, because of our last very high percent error, because of the wind, so the wind died down, and now we're going to try the experiment again in the same order. Alright. Angle of attack. Now we have the flat. Okay. Now, foiled. Okay, so here we're going to be talking about the concept of third law. Okay, so Newton's third law states that for every action there's an equal and opposite reaction. So in the system of an airplane right here, we have, so the force of the wing, which is actually pulling it up, so that would be lift, and then gravity pulling it down. So that would be the force of mg, gravity. And then, so as the plane has an angle of attack, that creates a drag, which slows down the airplane. And because there's an equal and opposite reaction, which was the drag, so the force that's acting is actually the thrust from the engines right here.